In this video, I'm going to discuss the concept of the molar mass. So just like atoms, single molecules are too small to weigh, and so we need a lot of molecules, and so we can use moles of molecules. So the molar mass is just the mass of 1 mole of a molecule. And so to get that, what we want to do is actually add up all of the atomic masses, those would be the numbers that we could get off the periodic table, and multiply each one by their subscript. So for instance, if we have carbon monoxide, which is just CO, that would be 1 times the 12.01 grams per mole. That's for the carbon. Then for the oxygen, we just have one of them, so it's 1 times 16.00 grams per mole. And when we add those up, we get 28.01 grams per mole. Then if we wanted to do dinitrogen pentoxide, that's N2O5, we would have to do 2 times the molar mass of nitrogen, so 2 times the 14.01 grams per mole, then 5 times the molar mass of oxygen, so 5 times 16.00 grams per mole, and when we add those up, we get 108.02 grams per mole. And we can do this for iron 3 chloride, so that's FeCl3. So we have 1 iron, so that's 1 times the 55.84 grams per mole. Then we add to that 3 times the molar mass of chloride, which is 35.45 grams per mole. And when we add those up, we get 162.19 grams per mole. And if we do the same thing for magnesium nitride, so that's 3 magnesiums, 2 nitrogens, so 3 times the molar mass of magnesium, so 3 times 24.31 grams per mole, plus 2 times the molar mass of nitrogen, so 2 times 14.01 grams per mole. We add those together and get 100.95 grams per mole. So again, we're just multiplying the molar mass of each element by the number of that element in the compound, adding all of those up, and that gets us the molar mass of that compound. And so we can use this to go between moles and grams of a substance. And to do that, we want to use this conversion factor where we can either use it as grams over moles or moles over grams. So when we go from moles to grams, we want to use it like this. We start with our moles, so we want to cancel out the moles, so we want to put grams on top. Then when going from grams to moles, the units should instead be arranged like this, where we now want grams on bottom so that it cancels out with the grams that we have, and we end up with moles in our answer. If we put all this together, the stuff that we talked about in the previous video and this one, we get this, where we can use the Avogadro's number here to go from the number of particles to the number of moles. Then we can use the molar mass to go from the number of moles to the number of grams. So let's go through a few examples here. We have the first one here, which is what is the mass in grams of 3.50 moles of lithium carbonate. So the first thing we want to do is come up with the formula for lithium carbonate. That's Li2CO3. So to get the molar mass, we want to multiply 2 times the molar mass of lithium, add to that 1 times the molar mass of carbon, add to that 3 times the molar mass of oxygen, and so we get 74.01 grams per mole of lithium carbonate. And so that is the molar mass of lithium carbonate. So then when we want to calculate the number of grams of it, we want to take the number of moles we're given, then we want to multiply it by our molar mass here, so that has the moles on bottom. So we want 74.01 grams of the lithium carbonate over 1 mole of lithium carbonate. That would give us 259 grams of the lithium carbonate for this one. The next one, how many moles are there in 17.90 grams of magnesium hydroxide? So the first thing we want to do is come up with the chemical formula for magnesium hydroxide. So that's Mg, then OH with a 2. And so we have 1 of our magnesium, so 1 times the molar mass of magnesium, plus 2 times the molar mass of oxygen. Remember, this 2 will distribute in and apply to both the oxygen and the hydrogen. Then 2 times the molar mass of hydrogen here. Add those together, we get 58.319 grams per mole of the magnesium hydroxide. So we start with our mass of magnesium hydroxide, then we want to use the molar mass, but now we have the mass on bottom. So now it's 1 mole of magnesium hydroxide per 58.319 grams of magnesium hydroxide. The grams of magnesium hydroxide will cancel out, and we're just left with moles of magnesium hydroxide. So this would give us the moles from the grams. Then this last one here, we're looking at how many hydrogen atoms are in 35.0 grams of methane. So this is putting together pretty much everything that we've been talking about in the past couple of videos. So again, we want to get the chemical formula, that's CH4. Then we want to get the molar mass for it, so 1 times the molar mass of carbon plus 4 times the molar mass of hydrogen. That gives us 16.04 grams per mole of the methane. So we want to start with the measured amount there that we're given, 35.0 grams of the methane. Then we want to use the molar mass here to get us into moles. That's the 16.04 grams of the methane that we calculated there on the bottom. Then we want to use the mole ratio of hydrogen to methane here. Every methane has 4 hydrogens in it, so it's 4 moles of hydrogen to 1 mole of methane. Then we use our Avogadro's number here. That's 6.022 times 10 to the 23 atoms of hydrogen per 1 mole of hydrogen. So when we calculate that out, we get 5.24 times 10 to the 24 atoms of hydrogen. And finally here we have some practice problems. As usual, I would encourage you to pause the video, try these on your own, and then watch the rest of it to see what the answers are. So I'm not going to go through how to come up with the answers. I will just give the answers. If you try this and you get it wrong, I would encourage you to look back at your work and try and figure out what it is you did wrong. So for the first one, we want to convert 540.0 grams of this lead 2 phosphate here to moles. So when we do that, we get 0.6654 moles of the lead 2 phosphate. The next one, we have convert 32.64 grams of water to moles. When we do that, we get 1.811 moles of water. The next one, we have convert 77.7 grams of this aluminum carbonate to moles of oxygen. So we want to find out how many moles of oxygen is in this. When we calculate that out, we get 2.99 moles of oxygen. The next one, we want to convert 0.555 moles of butane to grams. So when we do that, we get 32.2 grams of the butane. The next one, we want to convert 3.50 times 10 to the negative 4 moles of potassium iodide into grams. So when we do that, we end up with 0.0581 grams of potassium iodide. And finally, the last one, we want to convert 2.222 moles of this ammonium sulfate into grams of hydrogen. And so when we do that, we end up with 17.92 grams of hydrogen. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.